Hello everyone, my name is Muhammad Hadi Ali. I'm a 6th year med student at Beirut Arab University. I'm going to explain for you some topics about inflammation, and if you have any question, please don't hesitate to contact me at my email over here. Today's topic is the inflammatory response. But before we start, let me ask you this. Have you ever wondered why you get red, hot, swollen, and achy when you get a cut, for example? Or why you sometimes get a fever when you're sick? Well, today we're going to unlock the mystery behind your body's amazing defense system, which is inflammation. So what exactly is inflammation? Think of it like your body's personal alarm system and superhero team all rolled into one. It's a localized protective response that kicks in when your tissues get injured or infected. Its main goals are super important: to get rid of the cause of injury, to remove damaged tissue, and to initiate repair. But why does it matter? Understanding inflammation isn't at first just for doctors and scientists. It's something fundamental. It is fundamental to diagnosing and treating a vast range of diseases, just like infections, autoimmune disorders, injuries. It's also important in developing anti-inflammatory drugs that treat a lot of autoimmune diseases, and it's important to comprehend the body's initial defense mechanisms. A common misconception is viewing inflammation solely as a negative symptom just because it causes pain and swelling. But actually, it has an essential role as a protective and healing process. Inflammation is a good guy, it's not a bad guy. Inflammation happens in a series of really cool steps. We'll explore together how it starts, which is the initiation of inflammation, how your blood vessels react, which are the cardinal signs, how special cells join the fight, which is the leukocyte recruitment, and finally, what are the systemic effects of inflammation on our body. Our story begins with tissue damage. This could be anything from a tiny scratch, a burn, or even microscopic invaders like bacteria or viruses. The moment there is damage, special alarm cells called mast cells, which live in your tissues, get activated. These activated mast cells quickly release chemical messengers. Think of them as tiny signal flares. The most one is histamine, but they also release others like leukotrienes and prostaglandins. We also have another pathway that gets activated, leading to the creation of bradykinin. Bradykinin is a potent inflammatory mediator. And finally, damaged cell membranes release a substance called arachidonic acid. The arachidonic acid is then converted into more leukotrienes and prostaglandins through lipooxygenase and cyclooxygenase COX-1 and COX-2 respectively. Now all these chemical mediators like histamines, leukotrienes, prostaglandins, bradykinin, they all work on the blood vessels, causing two major vascular changes, which are vasodilation and increased vascular permeability. These two cause the four classical cardinal signs, which are swelling, redness, heat, and pain. First, let's talk about vasodilation. Vasodilation means the tiny muscles around your local blood vessels relax, making these vessels wider. You could imagine a highway suddenly getting more lanes. This would get the highway to have more cars. The same concept applies here. The blood vessels, when they get more wide, you could have more blood flow, and specifically, the blood flow would come to the injured area, resulting in visible redness and increased heat. As you could see here, when the vessels are dilated, it can handle more blood, and this blood would come to this area and would cause redness and heat. Second, these mediators also make your blood vessels leaky. They cause the cells lining your capillaries to contract, which are the endothelial cells, making gaps between them. This allows fluid called plasma and important proteins to leak out of the bloodstream and into the surrounding tissue. This leaking causes swelling, which we call also edema. And this swelling isn't just visible. It also presses on nearby pain receptors called the nociceptors, which sends pain signals to your brain. Plus, bradykinin directly activates these pain receptors, and in severe cases, swelling can even lead to loss of function, especially near joints. While all of this is happening in your blood vessels, your body is also calling in the big guns, which are leukocytes, or in other words, the white blood cells. These are your immune system soldiers. The leukocyte recruitment process mainly occurs over four main steps. First, we have margination or rolling. What happens is the inflammatory messengers we talked about, or mediators like histamines, in the second step it would be interleukin 1, interleukin 8, and TNF alpha. They cause endothelial cells to rapidly express adhesion molecules called selectins. So basically, in the blood vessels and capillaries, on their surfaces, they would have selectins. Leukocytes in the bloodstream have complementary sugar molecules that bind weakly to the selectins, causing the leukocytes to slow down and roll along the endothelial surface. In the second step, which is the firm adhesions, we have other immune cells called macrophages, which are found at the site of injury, which, upon encountering pathogens, they release other cytokines, which are interleukin 8 and interleukin 1, and tumor necrosis factor alpha. Interleukin 8 activates integrins on the surface of rolling leukocytes. So here we have the rolling leukocytes, and interleukin 8 would activate integrins that are found on their surfaces. This causes the leukocytes to bind strongly to ICAM and VCAMs, which are adhesion molecules expressed by the endothelial cells. This firm adhesion stops the leukocytes rolling. Now, for the third step, we have diapedesis, which is the extravasation of the leukocytes from the blood vessels. Previously, in the firm adhesion step, we said the leukocytes stopped rolling. Now, leukocytes squeeze through the gaps between the endothelial cells, facilitated by interaction with molecules like PCAMs to exit the blood vessel and enter the inflamed tissue. This is an amoeboid movement. Finally, once the leukocytes are in the tissue and out of the blood vessels, they aren't just wandering aimlessly. They are guided by a process called the positive chemotaxis. You could think of it like a scent that leukocytes are following. They follow increasing concentration of chemical messengers and cytokines, heading straight for the source of injury and infection where they're needed the most. Sometimes, if the inflammation is really severe or lasts a long time, it can trigger widespread responses throughout your entire body. One of the most common systemic effects of inflammation is fever. Inflammatory cytokines, like the ones we already talked about, like interleukin 1 and TNF alpha, they travel through the bloodstream to the hypothalamus in the brain. They tell your hypothalamus to release another chemical, which is prostaglandin E2, which resets the body thermoregulatory set point. But this high temperature can actually help your body fight off germs and speed up your body's healing processes. These same cytokines can also send a signal to your liver, which could produce various proteins such as C-reactive peptide. Doctors often measure CRP levels in the blood because high levels can be a sign of active inflammation in your body. And finally, these cytokines also tell your bone marrow to increase the production of white blood cells, monocytes, and eosinophils. This leads to an increased white blood cell count overall, a process which is called leukocytosis. It means your body is mobilizing a lot of soldiers into the fight. So let's recap some key takeaways. First, inflammation is super important for your body's defense. It protects you from infections, helps you heal, and keeps your body in balance. It's a very organized process involving lots of different cells and chemicals. Cardinal signs, these are the classic signs of inflammation as we discussed earlier, which are redness, heat, swelling, and pain, and may even lead to loss of function. They are direct manifestations, as we said, of the underlying vascular and sometimes the cellular changes. And for the systemic impact, even a localized injury can trigger a whole body response like fever, acute phase reactants, and increase in white blood cells. It shows you how your entire body works together to protect you. And that's the amazing story of inflammation. The next time you see redness or feel a little warmth around a cut, you'll know exactly what's going on and appreciate your body's incredible ability to protect and heal itself. Thank you for watching.